Let me welcome all of you to the lecture number 22 of drilling and blasting technology. From last class we are continuing with the explosive properties, and let us continue with that. So, at the very beginning, let us retrospect the previous lecture. In last class we are being introduced with the explosive and explosive accessories, and we have discussed the explosive properties of density and VOD, which are very important properties, but there are few more important properties there. Let us discuss those properties here. So, objective is our learning objective still remains same from the last class, that we are willing to know the physical explosive properties, chemical explosive properties, and how to what are the testing measurements, testing or measuring procedures for those properties we are trying to understand in this lecture. So, like very beginning, let us observe another demolition blasting. You can see this is a very multi-storied building which is being demolished by the explosive. You can see how beautifully the complete building is basically vertically getting down by demolishing without a little effect to the surrounding. So, basically this is one of the extreme use of explosive technology. The last one is the much better than this one. This is the extreme use of explosive technology for some civil or commercial use. So, if you carry out you demolishing this building using some manual or other mechanical method, like using big hammers or the manual hammerings, putting levers, the time requirement and the cost requirement will be much higher than these cases. You can see this complete area has been demolished using the blasting method maybe in few seconds. So, the method, if it is instead of using the explosive, if it is carried out by the mechanical or manual way, probably the time requirement was more than a year. In this case it is in few seconds. So, that is why this demolishing blasting is nowadays very popular, especially in case of those where the surrounding populations are very high and the controlled demolition of the building is essential. So, let us go to our next important property, that is strength. Strength of an explosive is basically considered as the power of the explosive. Though the strength of explosive is closely related with the VOD, but still it is little way different. The strength of explosive basically dictates the energy released from the explosive. So, on detonation, an explosive released energy in the form of gas and shock. The produced gas from the exothermic reaction are subjected to high compression because of its confinement, and the heat energy produced from the exothermic reaction gives the adiabatic expansion of the expansion or compression of the gases. So, basically on detonation, explosive first produce the shock, then then the gases are produced, and as it is a confined condition, the gases are in highly confined pressure, because those gases are also hot in nature because of this exothermic reaction. So, basically strength dictates the energy content in the explosive, and that is why the strength can be classified in two groups. One is the absolute strength and another is the relative strength. The absolute strength is the absolute measure of the energy of an explosive, and often it is expressed in terms of joules per gram or calorie per gram. So, this the strength of the explosive when it is measured in joules per gram or calorie per gram, this is called as the absolute strength. In general, the absolute strength of an explosive is obtained from its chemical reaction, or there are some empirical formula available from where the VOD is utilized to get a nearby value of the absolute strength. Often the strength of an explosive is expressed in comparison with the strength of another explosive whose strength is known, is called relative strength. So, when with respect to X explosive whose strength is known to us, or we can consider that as a base or standard explosive, if we express the strength of some unknown explosive on the proportionate ratio of that explosive, it is considered as the it is called the relative strength. So, absolute strength in general determined from the chemical reaction. However, there are a number of empirical equations available to determine the absolute strength, and relative strength also can be calculated from the theoretical chemical reactions, also can be measured from the physical tests. So, this is the ballistic mortar test which is carried out to measure the relative strength of an explosive. What is the ballistic mortar? Next slide we will see the figure, but ballistic mortar is basically comprises a pendulum fitted with a ballistic mortar inside the pendulum. Specified quantity of unknown explosive is detonated to trigger a projectile from the mortar. As the projectile leaves the mortar, the pendulum oscillates in the opposite direction and the maximum angle of oscillation is noted. The oscillation of unknown explosive is compared with the oscillation obtained from the standard explosive, and thus the relative explosive strength is measured. So, this is the ballistic mortar, this is the ballistic mortar which is placed in a pendulum, and you can see the enlarged ballistic mortar. This is the projectile, this is the projectile, and the explosive are placed at this position. When the explosive is placed at this position and the detonation is given to this explosive, then the explosive generates shock and huge quantity of gas which throw this projectile towards this direction, and then projectile removes the pendulum from this. So, the projectile removes the pendulum in this direction and allow the pendulum to oscillate in this direction. So, there is a mark on the pendulum which when reaches in the final position stay at that position, and that point is marked on the scale. So, this is the scale which gives us the angle of oscillation. So, the maximum oscillation angle is monitored and measured on the scale. So, basically in a nutshell, it is a pendulum this is a pendulum in which a ballistic mortar is placed. This mortar is allowed to send a projectile in this direction, and on reaction of this pendulum oscillates, and the maximum oscillation angle, this maximum oscillation angle is measured. and the strength of the explosive is calculated using the formula 1 minus cos theta by 1 minus cos theta for the standard explosive into 100. So, if we are carrying out the test first with the standard explosive and we measure the theta standard, then we carry out the same test with the same quantity of unknown explosive and measure the theta, we can identify the relative weight strength of the explosive. So, here is another type of classification possible with this, that is the absolute strength again can be classified in the two part. One is the absolute bulk strength, another is the absolute weight strength. Absolute strength when it is expressed in joule per centimeter cube or calorie per centimeter cube is called absolute bulk strength. Otherwise, if it is expressed in calorie per gram or joule per gram, then it is called absolute weight strength. So, when the explosive is expressed in weight and the strength is expressed in joules or calorie, in that case it is absolute weight strength. If the explosive is expressed in volume and the strength is expressed in joule or calorie, it is called absolute bulk strength. Relative strength can be further classified into two groups. One is relative bulk strength, another is relative weight strength, and again as same as if it is expressed in terms of volume, it is called relative bulk strength. If it is expressed in terms of weight, then it is called relative weight strength. Now, let us calculate one problem, solve one problem, so that we can understand the dependency of these strength parameters, absolute strength parameters, relative strength parameters, absolute bulk strength parameter, relative bulk strength parameter, absolute weight strength, relative weight strength parameters, how they are interdependent to each other. Let us solve two problems, we can understand easily by solving these problems. So, consider the relative weight strength of emulsion is 80% with respect to TNT. Okay. That means, the 1 kg of emulsion, how much energy it is producing, that is 80% of the energy produced from 1 kg of TNT. Second statement is given, relative bulk strength of ANFO is 20% with respect of TNT. That means, 1 meter cube of ANFO is exerting 20% of the energy produced from the 1 meter cube of TNT. After that, it is given that the specific gravity of TNT, emulsion and ANFO are 1.6, 1.2 and 0.8 respectively. Then the question is asked, determine the relative weight strength of emulsion with respect to ANFO. So, let us solve this problem. Now, relative weight strength of ANFO with respect to TNT comes 0.2 into 1.6 divided by 0.8. How? Let us solve this. So, let us solve this by hand. Say we know the relative bulk strength of ANFO is 20%, that means 0.2. So, N4, same volume of N4, same volume of TNT is equal to 0.2. Now, let us convert this volume to the weight. Okay. Then we multiply with the specific gravity here. So, that means if we erase the volume, make it, then we make it weight, then this should be multiplied with the density, that is 0.8, and this should be multiplied with the density, that is 1.6. So, weight of N4, that means strength obtained from same weight of N4 and strength obtained from same weight of TNT is equal to 0.2 into 1.6 divided by 0.8, which comes 0.4. So, this is nothing but the relative weight strength of N4 with respect to TNT. Okay. So, the first statement is now clear. Now, let us look into the second part. We know relative weight strength of N4 with respect to TNT is 0.4. We know the relative weight strength of emulsion. With respect to TNT is 80.8. So, weight of emulsion, energy obtained from weight of emulsion, energy obtained from weight of same TNT is equal to 80%, that means 0.8. Now, we are having also weight of N4, energy obtained from weight of N4, energy obtained from same weight of TNT is equal to 0.4 as we have calculated at this place. So, if we are dividing these two, that means weight of emulsion, weight of TNT divided by weight of N4 divided by weight of TNT, then this part will be cancelled. So, it will become weight of emulsion by weight of N4, and this value will be 0.8 divided by 0.4, that means 2. Okay. So, this is nothing but, this portion is nothing but relative weight strength of emulsion with respect to N4, that is coming 2 means it is 200%. So, basically from this problem we are able to understand how we can convert the relative bulk strength into the relative weight strength. Okay. So, now this conversion between the relative bulk strength to weight strength, or in other cases bulk strength to weight strength, which may be relative or absolute, we can do it for both the cases, is possible from, as our understanding we can see from this problem. Let us see another problem. In this problem, we will try to understand how we can convert between the absolute strength and the weight strength. So, what is the problem? This problem is that consider the absolute waste strength of ANFO. Consider the absolute waste strength of ANFO is 880 calorie per gram. Relative bulk strength of emulsion with respect to ANFO is 180%. Then determine the absolute waste strength of the emulsion if the specific gravity of the emulsion and ANFO are 1.2 and 0.8 respectively. So, first here what we need to do? We have to find out the how much energy absolute waste strength of the emulsion. So, that means how much energy we can obtain by detonating 1 gram of emulsion. So, one part is given, absolute waste strength of ANFO is already given to us. So, absolute waste strength of emulsion with respect to ANFO, relative waste strength of emulsion with respect to ANFO can be obtained by this 1.8 into 0.8 by 1.2, that is the ratio of the density of the explosive. So, let us elaborate this to understand. It is given the waste strength of ANFO is 880 calorie per gram. Relative bulk strength of emulsion with respect to ANFO is given. That means, 1, considering the energy obtained from the volume of emulsion, and energy obtained from the volume of ANFO is equal to 1.8, that means 180%. Now, let us convert the volume into weight. So, to convert this volume into weight, we have to multiply with the density, that means for emulsion it is 1.2 and for this it is 0.8. So, now energy obtained from the weight of emulsion, energy obtained from the same weight of ANFO, this ratio is nothing but the relative waste strength of emulsion with respect to ANFO is equal to 1.8 into 0.8 by 1.2, that is equal to 1.2. Okay. So, that is coming 1.2. So, this is now easily obtained, that relative waste strength of emulsion with respect to ANFO is now known to us. Now, let us see the second part. In second part, we have to determine the absolute waste strength of emulsion. So, we know the weight of emulsion energy obtained from the emulsion divided by energy obtained from ANFO is equal to 1.2. Energy obtained from unit weight of ANFO is nothing but 880 calorie. So, energy obtained from unit weight of emulsion is 1.2 into 880, that is coming 1056 calorie per gram. So, we are now able to convert between the relative waste strength, absolute waste strength and between the bulk strength and the waste strength. So, from absolute to the relative and from the bulk to the weight. these conversions are possible if we know the density of the explosive and their relative or some of their relative strength parameters and some of their absolute strength parameters. If we know those things, we can easily determine the strength parameters of any explosive. Nowadays, earlier actually the standard explosives are considered as the TNT. Nowadays, ANFO is considered as the standard explosive, and every time the relative weight strength which is expressed, that is expressed in terms of with respect to ANFO, considering the weight strength of the ANFO is 100 or bulk strength of the ANFO is 100, considering that the strengths are in general proposed. So, we can continue the properties of the explosive in the next class also. Before that, more reading can be carried out from these reference books. Thank you.